If you've been asked to draw a histogram in order to graph a distribution, then it's very likely, as a follow-up question, that you're going to be asked to describe the distribution. If they ask you to describe a histogram that you've just finished drawing, essentially what they're looking for is you to comment on whether or not your distribution is symmetrical. Now it's either going to be symmetrical or non-symmetrical, and I'll get into how you express that. But first of all, let's talk about what it means to be symmetrical, just in terms of idealized forms. What I mean by that is, ideally, if something is symmetrical, it would look like this kind of a histogram. You're going to see that with a symmetrical distribution, it's possible to draw a line down the center, and to either side of that line, you'll see sort of a mirror image of frequencies and categories. Now, it doesn't have to look exactly like this. It could, well, there's any combination. You could have something where it peaks towards the outside or the outsides, and so you have your line of symmetry like this. Later on in the course, we're going to deal with a lot of smooth curves, and so this will be a very typical symmetrical distribution that you'll see. So all of these are symmetrical. They all have that center line, that line of symmetry, where you get a mirror image to either side. Now, if it's not symmetrical, then it's termed as being non-symmetrical. And I would say that my example that I've got up here, the number of siblings that we went through how to draw this histogram a little bit earlier on, I would say that this particular histogram is not symmetrical. So this is non-symmetrical. But that's not how I would describe it. If it's non-symmetrical, you're supposed to comment on which way it's not symmetrical. And there's two ways to do that. There is calling it negatively skewed, and the opposite of that is positively skewed. And they each have their own sort of idealized form. A negative skew, instead of looking like what I've got here, where it has that line of symmetry where it's the same on either side, a negative skew looks like this. If you think about a histogram as starting at 0, having the frequencies on the side and the x values here, a negative skew has what would look like a symmetrical distribution, except for the fact that it's been stretched towards one side, and that side is the low numbers, and so it's got this extra tail that sticks out here, and so this is negatively skewed. They call it that because if you wanted to show your negative numbers on a graph, they would be below 0. So these are the negative numbers over here. So you can imagine that a positively skewed distribution is the opposite. It's a symmetrical distribution that has been pulled towards this side. Actually, let me redraw these. I think I've done a bad job of expressing what these should look like. Let me exaggerate them a little bit more so you can see the difference between a positive and a negative skew. Okay, so I'll just redraw my axes, and then, okay, a negative skew is going to be like this, and a positive skew is going to be like this. Okay, so I think that's a bit better. It looks like it could have been symmetrical if it had come down here, except we've got this extra long tail going towards the positive number, so that's a positive skew. Over here with the negatively skewed distribution, it would have been symmetrical if it had dropped down quickly, but it didn't. Instead, you've got this tail pulling towards where the negative values on a graph go. So which one do we have with our number of siblings example? Well, I would say that this one looks very much like a positively skewed because the tail pulls this way. So if I've been asked to describe this distribution, I would simply say that it is a positively skewed distribution. Okay, so what about our other example? We did another example where we had a histogram and it was it had to do with number of passengers. So let's go to that. Okay, so here's the histogram, and remember we are supposed to be commenting on whether or not it is symmetrical. Now, this doesn't look perfectly symmetrical. If I was to draw a line down the center of this distribution, and in an attempt to find like a line of symmetry, I guess I would put that right around here. And you can see it's not exactly the same to either side. However, we're never going to find, when we're collecting data in the real world, we're never going to find a perfectly symmetrical distribution, or it's certainly not going to happen very much if it happens at all. So instead we're just looking for general forms. So is this for the most part symmetrical? I would say yes, it is. It does look generally like this kind of a shape, which is symmetrical. Now it drops off here a bit more than it does on the other side, but for the most part I would say that this is symmetrical. If you're uncomfortable just simply saying it's symmetrical, you could say that it's somewhat symmetrical, or it's fairly symmetrical. Typically what a professor will do when they're designing an exam or an assignment is they'll make sure that if they're asking you to describe a distribution, they're going to exaggerate the shape. So if they want you to say that it is not symmetrical, they'll give you something that ends up looking like this. So you certainly would never make the mistake of saying that this is symmetrical. The last thing that they want is for students to be arguing that every one of their answers, every one of the different answers that different students have given are all correct. So this would be what they would show you if they wanted you to comment on it being positively skewed. If they want something symmetrical, this is close. I would say that this is very close to being symmetrical. They might fill in the frequencies here just a little bit more. But I'm going to stick with calling this fairly symmetrical, or simply just calling it symmetrical. And again, that's all that we need at this early part of the course to be able to describe the distribution. You might comment on, later on we're going to get into commenting where we see most of the data. So we see most of it clustered around this area here. So that's from about 35 passengers all the way up to 59 passengers. But all we're really looking for is that description of shape. In the next chapter, we'll start talking about where the center of a distribution is, or where the central tendency is. So this is a fairly symmetrical distribution.